no requirement for any database. But then there is another problem. They want to secure the access between the services there, so in the cluster. How can they observe that? How they can install some authentication or authorization policies in there, or maybe a rate limiting. So basically, to answer that question, people tend to look at service meshes. So basically, service meshes like Istio offer some capabilities like encryption, telemetry, health checks out of the box. And to configure all these little sidecars next to your workloads, then you need a control plane that will push the configuration to your Envoy sidecars, right? So at the end, you will secure the ingress in your cluster and the communication between your workloads in the cluster. And this is basically the final picture that we want to give to our customers. So basically, you want to add some security policies between the devices or the clients to the services of the pod, and also you want to add some security across the microservices. And you want to do that in a consistent way across cloud providers, across your clusters, okay? So, and just a few more words about the main difficulties here. When you are using multiple clusters, let's say here Red Hat and GKE, AKS, EKS, then you want to allow communication between services. What happens is that actually the traffic goes through what we call east-west gateways, okay? That will enforce some authentication or authorization policies. So what we have seen over the last few years is some competition in the service mesh landscape, and we think that Istio is somehow winning the race. Because I think Istio is backed by hundreds of companies. Like, it's a big community contributing to the Istio code base, and it's deployed at scale in many companies. And it was just given to the CNCF this year. So it has graduated, I think. Not sure about that. And also, our company, Solo, we also have worked with Google and a few other companies to bring a new model to Istio, which is called Ambient Mesh, which basically allows you to deploy Istio in a sidecar-less mode. So you are not obliged to have sidecars everywhere. And this is another topic, and we have a ton of materials and video recordings on our website about that. Well, so still, there are two main issues with Istio. First, the Istio Ingress Gateway is not a full-featured API gateway, so you still need to have an API gateway and Istio to manage all the security north, south, and east, west. And also, it's still complex to use and to maintain, to manage. So that's basically why we have built this Gloo platform, which comes with all these north-south traffic capabilities, where we leverage Envoy. We also extend Envoy, which is basically the ingress gateway in Istio, if you know a bit about Istio. And we have added more features there in this Envoy instance with more capabilities I'm going to sit in a minute. And we have also extended Istio for better operations. Also, we leverage Cilium if you are using Cilium in your cluster. So a few more words about this platform, Gloo platform. Basically, you will end up with one single API to configure everything north-south. So basically, you will configure your API gateway to enforce authentication, authorization, rate limiting, caching, everything in this space. And also, you will we have extended Istio to bring this concept of multi-tenancy that I will explain further in a few minutes, so that you can isolate workloads from different teams, for instance, or different tenants. And you can easily then implement zero trust networking in your cluster or across your clusters, and you will see that how. And we have also added some observability capabilities on top of that. So we are building on top of Envoy, Istio, and Cilium again, and we provide enterprise support to companies working with this Gloo platform. We provide enterprise support to Gloo, of course, and to these components, which are Envoy, Istio, and Cilium. So the main service mesh capabilities you would be interested in is, of course, enabling MTLS, but also maybe having Istio running on multiple clusters. So to do that, you need to, what we say, you need to federate the identities, because if you want some workloads running in different clusters to talk together and to enforce MTLS, then you need to have a common root certificate. And so it's a bit tricky to do with Istio. We have automated all of that. We also have what we call an Istio lifecycle manager. Yeah, it's like a kind of operator that helps you to deploy, upgrade, and do everything with Istio. And also we have a UI I will show you in the demo, but this is the kind of visualization you will see. So enough said about the Istio itself. I have said that we have extended Istio to bring this concept of workspaces. So if you consider this picture here on the left, you see a lot of applications, let's say, in a cluster, but maybe these applications belong to different teams. So let's say there are team A, B, and C with different pods or deployments, and they probably not want to share access to all their applications to each other team. So to group them together, you need to set some boundaries, and these boundaries can span multiple clusters. Here you can see cluster 1, 2, and 3 with different teams having applications running here and there. And if you want to isolate them together or to group them together, you can do that with this concept of workspace that works on multiple clusters and multiple namespaces. All right, so in the end, you will have that. Each team owner or each workspace owner can decide if they want to expose some services to other teams or if they want to deny every access. And this is basically how you can start implementing zero trust networking. Well, so now let's move to the topic of the workshop today. So the demo will try to combine both Istio as a service mesh and web authentication, which is basically a modern web framework to help you to do authentication in a passwordless manner. So here is the big picture of the demo. So we will have an end user like me and you, that you will be able to test it on your smartphone if you want. And the goal here is you as an end user want to access this backend application. And to do that, you will send a request to the Istio Ingress Gateway. That again is an Envoy instance we have extended with more capabilities. And when the request will reach this Ingress Gateway, it will trigger some authentication with a Keycloak instance I have already deployed on a cluster. I will show you that. So that you can authenticate or create an account and don't use any password, just maybe your fingerprint or on your smartphone. And then if the request is allowed, we will let you access the backend application. Make sense? Well, cool. So a few words about WebAuthn. It's a modern web standard that it is implemented in most of the web browsers that basically help you to authenticate yourself using your device. So it can be your smartphone, your laptop, anything that, or YubiKey, everything that helps you to authentically or physically authenticate yourself. And it's based on cryptography. So basically, when you first register to create your account, you will use your fingerprint. Your device will accept it. It will generate both a public key and a private key. Send the public key to the server, and that's it. Then you're registered with your public key on the server. So with this schema, what you see here is when you trigger, when you want to implement WebAuthn, then the server will send a challenge to your browser. The browser will use your device to authenticate yourself with your authenticator. So again, that can be any device that helps with passwordless authentication. What we often see and what we will see today is using a fingerprint. And once you're authenticated on your device, then the authenticator will generate a new keeper and send the public key again back to the server with some sort of challenge. And with that, you will have an account existing on the server. So if the public key is leaked, it's not a problem. What matters is your private key in the authenticator device. Well, so let's put that in colors. So the demo today will consist of these 3 different teams we generally see in companies. Let's say there will be a platform team who is in charge of managing the API gateways and also Kubernetes, why not? A security team who is in charge of everything security, like the IDP, identity provider, or the certificate management. And let's say one team of developers creating APIs. So again, generally companies are using multiple clouds. Can be public clouds like here with Google and AWS, or on-prem. Most of the time they're using both type of deployments or infrastructure. And I have just explained that we will have a platform team that will manage gateways or API gateways in the different clusters, as you can see here. Okay. Also, we will have a security team that will manage the security components, like the identity provider, that will be Keycloak today, and some user directory. And the developers will push or deploy applications here and there, specifically on public cloud providers. Okay, it's a bit complex for a demo, so let's simplify it already. So we will work this way today. So I have already prepared 3 clusters, 2 on GCP with GKE, okay, on different zones, and 1 on AWS with an EKS cluster. So the GCP clusters will run the developer applications, that will be HTTP bin today. And on AWS, we will use the public load balancer to expose our Istio Gateway, so that then we can enforce authentication here at this level, and also delegate the authentication to Keycloak. Well, so just again, to come back to this concept of workspaces, we have 3 different teams. The platform team is in charge of the gateways, the developers manage the applications here, and the security team is in charge of the Keycloak, right? So to define the boundaries of these workspaces, like everything with Gloo, you will use CRDs. So we have particular CRDs that help you to configure and to define workspaces. The workspace CRD helps you to define these boundaries. So let's say the gateways workspace will use all the clusters and specifically select these namespaces, the Istio Gateways namespace, where these Istio Gateways are running. The team workspace will embed the GCP clusters and more specifically the HTTP bin namespace. And let's say the security workspace or the IDP workspace will just use the AWS workspace and this particular auth namespace where Keycloak is deployed. All right. So a few words again about Gloo. Gloo platform. So basically, you need a management plane that will configure Istio here and there on all your clusters. This management plane can run everywhere, so it can be on one of those clusters or another cluster, and it will generate all the Istio configuration for you to configure everything, all the security for the north-south traffic and the east-west traffic. It will also gather the metrics. Excuse me one sec. Need some water. All right, it will gather the metrics, the logs, and everything, federate the workload identities, as I have explained, and do more stuff. So if we put that in perspective with our current setup, I have deployed Gloo Mesh Server, the management plane on the AWS cluster, and also I have deployed Gloo agents on all clusters, so that the configuration you will create with Gloo Mesh resources will be passed to all Gloo agents on all the clusters to configure Istio-D locally. So basically, you create some configuration here with Gloo Mesh Server. This is passed to the Gloo agent. Then the Istio policies like authorization policy, peer authentication are passed to etcd or the API server, and then Istio is watching these CRDs and enforcing security on the gateways or on the sidecars. It's a bit complex, but you get the main idea of this distributed system. Okay, so now about the authentication, the big picture again. We will use either your smartphones or my laptop to authenticate on this domain name. I will give you the link in a few minutes. API.adp, like Apidays Paris.solar.io. We will access a domain name. Then you will be able to both register and authenticate yourself before accessing the HTTP bin applications. And to do this, to enforce this policy and to do the routing to the HTTP bin applications that if you see that are running on different clusters, we will use Gloo mesh CRDs that will be then transformed into Istio CRDs. All right. So yeah, I will show you how I have configured Keycloak to enforce passwordless authentication in a minute. But before that, a few words about the routing. So in a cluster with an Istio ingress gateway, to do the routing, you will use Gloo CRDs, like a virtual gateway, which represents an Istio gateway or an envoy listener, the same thing. And you will use another object that is called route table to do your routing. And on each route, you can add labels, and then you can use policies that will watch these labels and enforce more security concerns. All right, so what you will see in the demo, I will speak for 5 more minutes, then it's the demo. What you will see in the demo is I will apply, or not sure where I am right now in the setup, but you will see this virtual gateway, which represents an Istio ingress gateway. Thank you. You will see route tables that define how you want to route the traffic, depending on the domain name, on the path of the request. And also, we have this notion of virtual destination that is really interesting because basically it defines a destination using Kubernetes service labels that can run everywhere. So it could be running only here, or only here. And basically, the virtual destination will configure the Istio gateways and sidecars so that it's targeting the workload where it's actually running. So it's really interesting, especially for lift and shift concerns. All right. So with that, we will also, and it's the end of the theory, then it's hands-on. We will also have these other policies you can see here that will help us to enforce authentication for this particular HTTP bin application, to enforce some WAF policies or JOT policies. Basically, we want to extract some claims from the ID token, the OIDC token, and to create new headers dynamically with those claims. And also in the WAF policy, basically what we have done is we have added new filter in Envoy embedding mod security for people who are a bit aware of security firewalls in general. So last point on this picture is, again, if you look at the workspaces, what you see is that the platform team will manage the ingress gateway and the east-west gateways, and also the global policies like which domain names I want to listen on and how I want to configure the access to the authentication server. The developers, we are able to decide how they want to secure the access to their applications, maybe using enforcing authentication, enforcing the WAF, enforcing JOT policies, and the security team will expose their IDP, for instance, all right, and create a route table to configure the gateway so that the Keycloak can be exposed as well. All right, I think it's time to move to the demo. Wait a sec. I hope it's clear for everyone about the purpose of the demo. If you have questions, please, I can take them. Or at the end. So let's start with Keycloak. All right. So I said that today it's about enforcing passwordless authentication. So I have created a realm in Keycloak called the corp users, and basically I have configured it. Not sure I have Wi-Fi. Yeah, it should be. Okay, I need to re-authenticate. And I have configured the, actually, Keycloak is really powerful. I didn't even know a few months ago. But there is some sort of rules engine that is extremely powerful. And basically, you can define your authentication flow. So what I have done here, I've created a particular authentication flow called WebAuthn. And basically, using these built-in policies, I'm able to ask users to either register or authenticate, and using this WebAuthn browser component, you can ask them to register or authenticate with the WebAuthn framework. So that's basically it. If you are interested in that, I will share the configuration with you after the workshop. So this is just about it, and of course, I'm not sure I've mentioned that, but WebAuthn works well with OIDC. So in this case, I have created a new OAuth client that is called Gloo, and these are my initial URL and redirect URL. And this OIDC client also have a secret, like every standard OIDC configuration. Right, so let's move to the technical part. These are the two domains we will use. And before you guys can try it and authenticate it, we have to create the policies. So this is the content of the workshop. I will explain you what I have already done, and then we will go step by step to enforce authentication, because it's not done yet. So I have created these 3 clusters, 2 on GCP, 1 on AWS. The one on AWS will be called management. All right, I have deployed Gloo or Gloo Mesh, which is a component of the Gloo platform that will manage Istio. So it's basically just a Helm chart, all right? I have registered all the clusters so that I have some sort of one single super mesh that consists of Istio on each cluster. We have workshops about that if you're interested, online workshops, free to access. I have registered the second cluster, and even the main cluster where the Gloo Mesh management server is running. I enable east-west communication. I'm using our Istio lifecycle manager to deploy Istio. So there are a few preparations here. And then, as you can see, it will use components like Istio lifecycle manager or gateway lifecycle manager, because just for you to know, it's always good to deploy, to have 2 Helm deployments or 2 deployments of Istio for managing on one side the gateways, on the other side the sidecars. So that's what we do with these CRDs, and I do that on all cluster. So deploying the Istio lifecycle, using the Istio lifecycle manager to deploy Istio everywhere. All right, and once that's done, I gather some endpoints. I also install our X-Auth service. That is another component part of the Gloo platform, which is basically a bridge between the Istio Ingress Gateway, then there is the X-Auth service, and then your IDP, so that it can trigger the OpenID Connect flow. All right, Keycloak should be deployed. I have already shown that with the WebAuthn application, and I think I have already created the workspaces that I have shown in the slides. So basically, how I define the boundaries of each workspace for each team. Okay. It's a bit too much to explain today, but we have another concept of settings for each workspace, where the workspace owner can decide which services they want to expose to other workspaces, or which one they want to import into their workspaces. Really interesting and powerful. And I federate the identities of all the Istio deployments or Istio, the clusters, so that they have one common root certificate. I've used Cert Manager to create real certificates for my gateways. And I think we're close to the start. Yes, it's still the certificate, virtual gateways. Let me check that. So what I have explained in the introduction is that we have this concept of virtual gateways that will configure the Istio gateways with some domain names and that we don't see here. Oh yeah, it's in a variable, and on some ports. So for instance, here I have created a virtual gateway with an HTTP listener, another HTTPS listener for these two domain names. Okay. Key clock should be exposed, yes, because we have accessed it. Demo starts here, finally. All right, so I have already shown you the key clock interface, and we will start by deploying what I have called a virtual destination. So just for you to remember, if I go back to the slides, the virtual destination is this component right here that tells Istio that a particular workload is running here and there. And to define that, I'm using a new virtual domain name that other services can use themselves in the mesh to consume that virtual destination, and it's selecting all the services in the HTTP bin namespace with this label, and it's targeting the port 8000. All right, so I will create that because I think it's not existing right now. Let me double check. So I'm on cluster 1, get virtual destination in all namespaces. As you can see, it's not ready yet. So let's create it. All right. And also I am applying this outlier detection policy, which basically says if the service is not answering correctly, it's not available. So please go to the other service, matching this the selector. And the last piece here is configuring a route table. So basically, I'm selecting a gateway, which is my north-south gateway, and I'm saying that for this domain name, the gateway domain name, which is api.solo.io, I want to route all the requests, like all the queries starting with prefix /, so basically all HTTP requests, to this destination, which is my virtual destination. A bit tricky, I can imagine, to understand at once, but you get the main point. Basically, I'm doing the routing to the HTTP bin application. And now I will test if I can curl my endpoint. And so, sorry, I was a bit fast here. So I have sent a HTTP request to my gateway on this /headers path, and it has returned all my request headers. So it's working, and the domain name is API-ADP-solo.io. You will test it in a second. Now, the next step is, as a developer, I want to enforce authentication so that people authenticate themselves before consuming my service. To do that, first, not as a developer, but as someone of the security team, I want to configure my OIDC server or IDP. So I create a few variables with an access token, sorry, not an access token, a client ID, client secret. I configure my XOF server because I can have different XOF servers. It's a lot of configuration here, but just say that we are configuring the bridge between the Istio Gateway and Keycloak. And then, as a developer, because as a developer I manage this HTTP bin namespace, I will define a new XOF policy. And of course, if you are the platform administrator, you can allow different teams or not allow them to use this kind of policies, or any policies like JOT policies, XOF policies, WAF policies, many more policies, using the Kubernetes airbag. All right? And what I'm doing here as a developer is for all the routes that have this particular label of true or of true, then I want to use OIDC. This is basically an OIDC configuration with client ID, client secret, and some more interesting stuff, but we don't have enough time to explore all of them today. So as a developer, I want people to authenticate with OIDC and with Keycloak, and we have configured Keycloak to authenticate with passwordless authentication. And the last step is to update our route table with this new label of true, so that my OIDC policy is enforced on that route, which is the route going to the HTTP bin application. All right, sorry. And now, if I open the application in my browser, then you see I'm redirected to Keycloak to authenticate myself. So I will let you guys play with this right now. So you can scan the code or just type this address in your smartphone, bit.ly/adp, like Apidays Paris -glue. It will take you to a GitHub gist where you will find a few addresses or URLs, and one of them is the application, and you will be able to test it yourself. So you will end up on this gist. Again, I'm just giving you a few more seconds to capture the address. All right. Good. Okay. You will see then this gist, and you can use this address. You can copy it and paste it or open it in a browser. And then you should be able to access the application. And remember, as a developer, I have asked the gateway to enforce OIDC. So what you can do after that is when you are redirected to this web page, you can register on the Keycloak instance, and we will see all your accounts here, maybe in the users tab. No users yet. Sorry. Sorry. So I'm doing the exercise myself. I'm registering with username Baptiste. All right, register. And now the browser is asking me to register with with my device, which is the fingerprint sensor on my laptop. Just a small pop-up, I accept, and I'm authenticated. If you want, you can also try the other links. Let me quit this page. There are a few other links in the gist here, so that you can try to log out and log in again. But you need to log out from Keycloak and also from the application. Okay, and then you can try to authenticate yourself again. And you will see that you will be prompted for your fingerprint to get access to the application. Great. So that's basically it. You can do the exercise. Not sure we have users there, but whatever. Then let's go a bit further in the demo. So these are the links. You've got them. Usually, what you want to do at the edge is to enforce more than just authentication. You want to do some sort of authorization sometimes. So here we will go just light on this. We will just want to extract some claims from the ID token that is returned by the IDP, identity provider. And we want to, so what you need to understand here in this new YAML thing is, first, I want to verify the issuer of my Keycloak instance, the issuer that is present in the ID token. My ID token comes from this header. I want to extract some claims from the ID token and to create new headers from them. So basically, with the name header claim, I will create this new header, and from the email claim, I will create this other new header. And let's see if we can see them in the application then, because these new headers will be passed to the application. So I'm just applying this JOT policy, and so that it works, we need to configure the Istio Gateway to connect to an external domain name, which is a public domain name of Keycloak, on using HTTPS, because it's not part of the mesh. So when in Istio you are targeting external services over HTTPS, you need to hint Istio about that. And there is this last thing to do to enforce TLS. And now, if I try to authenticate again or to refresh my application page, okay, what I see now is a bit different. If I zoom in, you see I have two new headers that were dynamically created using claims of my ID token, the OIDC token. That's great. So that you don't have to do that in all your microservices. Authentication is really handled at the gateway level. All right. And the next and final step here is to blacklist my own IP address from the gateway. And to do that, I will just first check the access logs of the Istio Gateway. So let's check the logs. Hopefully, I will see my own IP address somewhere. So it should be. Actually, I didn't configure the load balancer properly. So I think it's not my real IP address as a client. It's something in channel to AWS. Yeah, it was already the case yesterday. So what I'm doing here is I'm using a new policy, the WAF policy, that is embedding or wrapping mod security, and I'm enabling some core rule set policies. And if my IP is this IP, then I will deny the access with the 403 and with this message. So I apply this new policy, let's say as a developer. All right. And now if I refresh the web page, I should be denied. Okay, maybe take a few seconds. Okay, no, I'm missing something because no, it's on this particular route with this same label, so it should work. Let's refresh it again. Okay, not working. Maybe it's not the right IP. Let's try it again. Not taking the IP address is this one. All right, let's try it again with this IP address. At least I'm not cheating you with a fake API address. So, all right, I am applying this new address and refreshing the web page again. All right, now you can see my IP address was forbidden. So basically, you have all heard about the log4 shell attack a few months ago, and since we have embedded mod security, it was really easy for all our customers to prevent this kind of attack at the edge of their clusters, just using the correct mod security rule. I will remove this rule. Oops, sorry again. I should access it again. All right, everything is fine. And I think it's already the end of the demo. Just a few last words to close that. So you were able to see how you can combine modern technologies like Istio as a service mesh, web authentication as an authentication layer. And all of that, as you have seen, I have configured everything using one single management plane or one single software, which is Gloo, that is built on top of, again, Envoy, Istio, and Cilium. So that's basically what our customers like with this product. Thank you for your time and listening. I'm happy to take your questions, even in French. Does it make sense, this kind of use case, where to secure the gateway and the east-west traffic? Yep. All right. So, yep. That should be, sorry, so the token that we generate at the gateway, I didn't hear the end. So what did you say again, sorry?
When the user authenticate the first time and get the token,
yep.
It is the same token we use for the communication between S-to-S, between services?
Not really. So actually, the X-off policy that is created here by the developers will enforce authentication here at the ingress gateway. So the ID token or the OIDC flow is just executed here at this stage, at the gateway. Then for, actually I have not demonstrated here, east-west communication is just somehow, yes, just a bit, between the ingress gateway here in this cluster and other applications running in those two other clusters. And to accept communication between this Istio Gateway and this workload here, HTTP bin, we didn't see that is that it goes through what we call Istio gateways or other east-west gateways, and to allow this communication over MTLS, what was important in the setup was to federate the certificates, the identities of all the workloads with all the gateways. And that was somehow magically handled by the management plane that has configured Istio, so that Istio is using an intermediate certificate in each cluster, like here, sorry, here, here, and here, okay? In each cluster there is an intermediate certificate for Istio, and all these intermediate certificates are signed by the same root certificates. So that's how you can enable or federate the identities across the clusters. And what I didn't demonstrate, you're right, today, are somehow access policies between a workspace and another workspace. But what I have done, and I didn't spend much time on that, is I have enforced what we call service isolation in each workspace. So the developer workspace, the platform workspace, and the security workspace. So that basically they are not allowed to talk together except for a few services. Let me go back to the configuration. I have this workspace settings object, not that one, but that one, where basically I have said that the gateways workspace are allowed to access all the services in all other workspaces that have these labels, and all the let's say all the services that exist in other workspaces with this label. And also access the route table. So yeah, it's a bit abstract, but if you want to know more about how we handle really east-west communication and authorization, it's better, I think, to attend one of our workshops that are available online.
Okay, thank you.
Thank you for the question.